Welcome to qnawire.
Okay, so here we've got acetic acid. This is the bond line structure of that compound. This is the CH3COOH, if you didn't know. And we've got carbonate anion, right? So that's a carbon double bond oxygen, single bond to oxygen minus, single bond to oxygen minus. Each of these has 3 lone pairs. If you're curious about the Lewis structures, okay, I'm not going to draw on the lone pairs. It's not entirely necessary. The point is, I am going to highlight this proton. Okay, so the idea is when we go forward with this reaction, okay, actually, let's do this. Let's do the forward direction in pink. And we'll do the reverse direction in blue. Okay, when we go forward, the product we get is acetate, right? So it's acetic acid, but without that proton. And we get a negative charge here. And our carbonate anion will gain a proton. Okay. So in the forward direction, right, moving from left to right, what happens to our proton? Right? This proton gets transferred from here to there, right? If we want to, that would be the more accurate representation. But this proton is getting transferred to another molecule. So this must be the acid, right? It's losing a proton. This is our acid. And if this is the acid, this must be the base, right? So I'm going to do this in pink. We're talking about the forward direction. Acid, base, right? This proton ends up over here. Acetic acid loses a proton. Carbonate anion gains a proton. Okay. What about the reverse direction? This proton will move from the carbonate anion to the acetate, right? So it's the opposite. What that means is this is acting like an acid when we consider moving right to left. Okay, so this is our conjugate acid, and this is our conjugate base. Okay, meaning when we move from right to left, this is acting like a base because it gains a proton. And when we move from left to right, this is acting like an acid because it loses a proton. When we move from left to right, this acts like a base because it gains a proton. And when we move from right to left, this acts like an acid because we're losing a proton. That's what this acid-base, conjugate acid thing is always all about.